Okay, so here we have a pig heart and a cow heart, and we're going to go over some of the structures. We start with the pericardium. Remember, this is the fibrous sac, and I've taken it off. Normally the heart would be all wrapped up in it. All right, so we move that back. Then we have the epicardium, and that is almost like a thin film that hugs the heart. There it is, just that little skin right there. From there, we go to the myocardium, which is myo, middle, muscle. It's the middle layer. It's called the myocardium, and this is the actual cardiac muscle. And that's all of this. Then we have endocardium, endo meaning in. So this, all this smooth lining, this is endocardium. And you can see that the valves, we're going to identify here in a little bit, they're also made of this endocardium. And it's smooth so that it reduces any friction with the blood so we don't have any unnecessary clotting. Okay, so now we're going to learn anterior from posterior. All right, so when we look, this is the anterior surface. And one of the ways that we can tell that is if you look up here, the large vessels going in and out, they all look nice and smooth and they're going away from you. But if you turn it over to the posterior side, you see all these ugly holes facing you. And so this is posterior. All right, if we go back to the anterior side, you will see something called the anterior interventricular sulcus. Okay, so anterior tells you it's on the front of the heart. Interventricular means in between the ventricles, and sulcus is a groove, and that's where an artery and vein are going to sit in a little bit. This is our divider line. The apex, which is the point of the heart, is always the left ventricle. So from the apex up to the sulcus, all of that is left. From the sulcus up is all right. So now we know that this is our right ventricle and this is our left ventricle. Then we identify the atria. Now the atria don't have those strong muscles that the ventricles do, so they collapse when they don't have blood in them. So they kind of look like little deflated elephant ears. And we can see another one over here. And so this would be my left atrium. All right, so now we're going to go over the three sulci. This was the first one, anterior interventricular sulcus. Then if we turn it over, we have the posterior interventricular sulcus. And then our last sulci is the atrioventricular sulcus, which tells you it's in between the atrium and the ventricle. So you simply lift up the atrium, and that groove all the way around is your atrioventricular sulcus. And again, an artery and vein will go in this spot. Okay, so let's go over our four chambers. We have right atrium, right ventricle, left atrium, left ventricle. Now you can also see coming out of this right ventricle is the pulmonary trunk. Then behind it we can see the aorta, and that tucks back and then comes from the left ventricle. If we turn around here, we can see our vena cavas, and we can also see the vein attachment sites. All right, now let's go over to our cow heart, which is a little bit larger. All right, so when we're talking about right and left, this time we don't have our anterior interventricular sulcus to tell us. So we're gonna go by muscle mass. The right side of the heart is called the pulmonary circuit because it pumps blood from the heart to the lungs. That's not a great distance, so it doesn't need a lot of muscle, which you can see indicated here. The left ventricle needs more muscle because this is the systemic circuit. So this is taking blood from the heart to the body. Now, if you also notice that the right ventricle is very narrow but deep, where the left ventricle is wide but shallow. And if you remember back, we learned that the right ventricle actually wraps around the left, helping it get that little extra oomph every contraction to again pump that blood out to the body. All right, This is the interventricular septum. And remember, interventricular means in between the ventricles. This is where your bundle of His and bundle branches of the conduction system will run down. Alright, so now we know that this is our right ventricle, so we can trace that right back up, and this is my right atrium. Now, what you see here is a valve, and on the right side, that is a tricuspid valve. That is one of your AV valves, or atrioventricular valves. Now notice the valves have these little string things attached. Those are called chordae tendineae. Now if we go to the left side, we can see the left atrium, and we can see our other AV valve on this side. This is the bicuspid or mitral valve. And again, you can see those chordae tendineae or heartstrings. Now where the chordae tendineae attach in the ventricle is called papillary muscle. So everywhere we see that attachment, we can see that. Okay, so let's go over the structures that we just did. We have right atrium, tricuspid valve, right ventricle. Then we have left atrium, bicuspid or mitral valve, left ventricle. We have chordae tendineae and our interventricular septum. Now, since we are in the left ventricle here, you can trace that up and see that this is the aorta. Now, one last thing that we can see, all these bumps and grooves that you see inside the heart, those are called trabeculae carneae, and those are genetically unique to each of us. Much like fingerprints, no two hearts have that same pattern, which is also why no two hearts sound perfectly the same.